A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey Herman and Corn. So even when the occasions are a bit somber, like our recent episodes about everything to do with the Iran-Israel war, which is now started. So for those who want to listen back to many of the episodes where we analyse what was going on in the region, learned about the EWACS, and that's not earwax, EWACS, EWACS, the bow and grouter, and I think it's given me a huge appreciation for when we say the US is moving a massive amount of force to the region. It kind of sounds like on the surface one of those news bites, or we think, oh wow, a lot of fighter jets. And I feel like learning more about the capabilities that the US was deploying to the region increased my confidence and reassurance, and I have to say intrigue as well, but that's for another day. So it was good for anyone listening. Well, I would say if you're in shelter in Israel right now, maybe some lighter topics are better for distraction. But after the war, those were really good episodes. And I'm honestly grateful that AI is so good and that I was able to generate these with the help of our dear friends Herman and Corn. So Herman and Corn, I'd love to chat today about another facet of there's just so many facets of the Iran-Israel conflict that I think we could rename the podcast that, and I'd still probably find a few more hundred very niche questions to throw your way. But here's one that I'd love to chat about today, and that is the vital life-saving role of the emergency sirens. So in Israel, we have sirens, and we have a multi-layered civilian alerting system, in fact, which we've talked about before. We talked about the interesting case here whereby we have to come up with alerting systems that'll reach ultra-Orthodox users who don't have internet. And we talked about how there's a non-GSM emergency network that's used, and that thing would, I would say, wake the dead. It's like they've started using that during this and the last war as much as red alert, and it just gives this shrill beep that you will not miss, especially if you have a few smartphones in your home or a few phones, anything with an active SIM card in it. They will start very noisily beeping all at once. And if you're in a small Israeli apartment building where everyone is living close together, there's just this cacophony of beeps. So that's a good thing. But the last line of defense remains the actual air raid sirens. And I remember looking into this before, because it's just one of those things that we know exists. We hear them even during the more normal times in Israel. We hear the air raid sirens a few times a year because they're used for Holocaust Remembrance Day. And occasionally the military does do an announced test. So they'll tell you, it'll be in the news tomorrow, the Home Front Command is running a test. So even on a normal year, let's say, we hear them 3 or 4 times. But in the conflict, we've become quite accustomed to them. And I remember in the last conflict, a lot of these things are open source. If you're curious enough, the information is there. It's not a state secret. I remember just researching what are these things, like they're so loud, and how many of them do you need to actually cover a city. And was reading about them. I think they're German made, at least the model Israel uses. My wife, as you know, grew up in Texas, and they also have air raid sirens for tsunamis, and I think often use the same hardware. But I assume, like everything that we talk about in the preparedness aspect, we don't just put down, and the government doesn't just put down a number of these in neighborhoods and hope that it'll, the audio will get around the place and people will hear it. I'm sure it's very calculated. And I'd love to talk today about these systems. Because we talk about redundancy, I assume oh my gosh, Herman and Corn, I am seeing an interception streaking across the sky. This podcast takes on the look. We don't have the be in shelter thing. I encourage people to be in shelter when there is a thing, but alert. But I just saw an unmistakable, it looked like fireball streaking across the sky. Sometimes you see interceptions happening. They look like they're overhead, but they're somewhere else. That was pretty crazy. Anyway, sorry, back to the topic. So yes, when these things go off, they're very loud, they're very, I'm sure, robustly engineered, and they're very well calibrated to make sure there's enough of them. And with that, I should probably end this prompt and go into the shelter. So Herman and Corn, would love to know a little bit more about the actual mechanics of the air raid sirens that save lives, not only here in Israel, but other places where they occasionally have to be used to warn civilian populations. And the last line of defense, after the smartphone apps, after all the rest of it, these are the ultimate things that let you know that something is up.
That was quite the prompt from Daniel. You can hear the urgency in his voice, and honestly, seeing an interception streaking across the sky while you are trying to record a voice note is about as real as it gets. It is a stark reminder of why we do this show. We talk about the tech and the engineering, but at the end of the day, these systems are about protecting people like Daniel, Hannah, and little Ezra. It is February 28th, 2026, and while we often look at the future of gadgets, today we are looking at the infrastructure of survival.
It really is. And Herman Poppleberry here, ready to dive into the nuts and bolts of this. Daniel's observation about the sirens being the last line of defense is spot on. We have spent so many episodes, like episode 745, talking about the high-tech side of this, cell broadcasts, smartphone apps, and the incredible algorithms behind the Iron Dome and the newer Iron Beam laser systems. But when the power goes out, or your phone is on silent in another room, or the network is congested because everyone is trying to call their loved ones at once, you are left with the most primal mechanical warning system we have, a very loud, very specific noise.
It is interesting that we still rely on something that feels so analog in 2026. You would think by now we would have moved past the air raid siren, but if anything, the engineering behind them has only become more sophisticated. Daniel mentioned they are often German-made, and he is right, companies like Holman have been refining this technology for decades. But I want to start with the physics of it, Herman. How do you actually engineer a sound that can blanket an entire city like Jerusalem or Tel Aviv without leaving dead zones?
That is the ultimate acoustic challenge, Corn. You are dealing with the inverse square law, which tells us that the intensity of the sound drops off significantly as you move away from the source. Specifically, every time you double the distance from the siren, the sound pressure level drops by 6 decibels. In a dense urban environment, you are not just fighting distance. You have buildings, hills, and even atmospheric conditions like wind and temperature inversions that are actively fighting against that sound propagation. If you have a temperature inversion where the air near the ground is cooler than the air above it, the sound waves actually refract or bend back down toward the ground, which can sometimes make the siren sound louder further away than it does up close.
Right, and Jerusalem isn't exactly a flat plain. It is all hills and valleys and stone buildings that reflect sound in weird ways. I imagine the canyons created by the streets make it a nightmare for an acoustic engineer.
You have what we call acoustic shadows. If you are standing behind a massive stone building, the high-frequency components of the siren might be blocked, leaving you with a muffled, low-frequency version that might not be enough to wake you up or grab your attention. So, you can't just put one massive speaker in the middle of the city and crank it up to 11. If you did that, the people living right next to it would have permanent hearing damage. We are talking 150 decibels or more, and the people on the other side of a hill wouldn't hear a thing. The engineering solution is a distributed network of sirens, carefully calibrated using acoustic modeling software. Engineers actually use three-dimensional maps of the city, often generated via LiDAR or high-resolution satellite imagery, to simulate how sound waves will bounce off buildings and dissipate over distance. They aim for a minimum sound pressure level of about 70 to 80 decibels inside buildings, which means the siren itself has to be outputting somewhere in the range of 100 to 130 decibels at the source.
130 decibels is incredibly loud. That is the threshold of pain for the human ear.
It is. It is equivalent to standing next to a jet engine taking off. That is why placement is so critical. They are usually mounted on the roofs of public buildings, schools, or dedicated poles, high enough that the initial blast of sound is above the immediate heads of pedestrians, but positioned so the sound can wash over the neighborhood. They use something called ray tracing in their software, similar to how video game engines calculate light, but for sound waves. They can predict exactly where the dead zones will be and then place a smaller, secondary siren to fill that gap.
You mentioned mechanical versus electronic sirens earlier. Daniel's prompt touched on this too. What is the actual difference in how they produce that sound? Because the old school ones had that very distinct wind up and wind down sound, right? Like the ones we see in old World War II movies.
Yeah, the classic mechanical siren is basically a giant air pump. You have a motor that spins a rotor inside a stator, which is just a stationary outer housing with holes in it. As the rotor spins, it chops the air into pulses. The frequency of those pulses determines the pitch of the siren. That iconic rising and falling tone happens because the motor is literally speeding up and slowing down. It takes time for that heavy rotor to reach its peak revolutions per minute, which creates that haunting wail. It is a very robust system, but it is limited. It requires a lot of power to start that motor, and you can't really change the message. It is just a noise.
Whereas the ones they use now in Israel are mostly electronic, right? I have seen pictures of them. They look like clusters of grey horns pointing in every direction.
Correct. Modern systems are essentially high-powered public address systems on steroids. Instead of a spinning rotor, you have a bank of compression drivers, basically massive, weatherproof speakers, and a high-efficiency Class D amplifier. This gives the home front command a lot more flexibility. For example, in many parts of Israel, the siren isn't just a wail, it can be followed by a voiced command or a specific signal that tells you if it is a rocket attack, an earthquake, or a different kind of emergency. These electronic sirens can also produce a square wave or a sawtooth wave, which is much harsher to the human ear than a natural sine wave. That harshness is intentional. It is designed to cut through the background noise of traffic, air conditioners, and television sets.
And that brings us to the multi-layered part of the system Daniel asked about. The sirens don't exist in a vacuum. They are the loud, noisy tip of a very deep iceberg. How does the trigger actually happen? Because it feels like the sirens go off almost the exact moment the radar picks something up. In Daniel's case, he saw the interception almost immediately after the siren started.
The latency is incredibly low, which is a marvel of automation. The system is managed by the home front command, but it is fed by the entire Israeli Defense Sensor Net. We are talking about the ELM 2084 multi-mission radar, the same one that guides the Iron Dome, along with various electro-optical sensors that look for the heat signature of a launch. When a launch is detected, the system calculates the trajectory in milliseconds. It doesn't just say there is a rocket. It defines a specific polygon on the map where that rocket is likely to land. This is where the engineering gets really impressive. They have divided the entire country into over 1,700 distinct alert zones.
This is the part that always fascinates me. Back in the day, if a rocket was fired at Tel Aviv, the whole city would go into shelters. But now, it is much more surgical.
It has to be. If you disrupt the lives of millions of people every time a small rocket is fired, you are doing the enemy's work for them by paralyzing the economy and the society. So, the system identifies which polygon is at risk and then sends a trigger signal to only the sirens in that specific area. If a rocket is headed for the north of Jerusalem, the sirens in the south might stay silent. This precision reduces alert fatigue, which is a huge psychological factor in civil defense. If people hear sirens that don't apply to them too often, they start to ignore them.
How is that signal sent? Is it over the internet? Radio? I imagine it has to be something that can't be hacked or jammed easily.
It is redundant, as you would expect. There is a dedicated radio frequency network that is independent of the civilian cellular grid. This is crucial because, as we discussed in episode 793, civilian networks are the first things to fail during a mass emergency. If everyone grabs their phone at once to check on their family, the towers get congested and the data packets stop moving. But the Siren network uses a hardened, encrypted RF signal, often in the VHF or UHF bands, that can penetrate through buildings and isn't affected by cell tower congestion. There is also often a secondary landline connection or even satellite links for the most remote areas. The Siren itself has a control unit at the base that is constantly listening for its specific digital address. When it hears the code for its polygon, it activates the amplifier and starts the wail in less than a second.
So the signal hits the siren. The siren starts wailing, but at the same time, my phone is screaming, the TV is showing a crawl, and the radio is interrupting the music. That is the multi-layered aspect.
You have the external layer, which is the sirens. Then you have the personal layer, which is the cell broadcast and the home front command app. And then you have the media layer, TV, and radio. The cell broadcast is particularly interesting. We did a deep dive on this in episode 745, but it is worth a quick refresher. Unlike an SMS, which has to be routed to your specific phone number, a cell broadcast is a one-to-many signal sent to every phone connected to a specific tower. It doesn't matter if the network is full. The broadcast has priority at the hardware level. It bypasses the standard operating system and triggers a unique sound and vibration pattern that you can't easily silence.
But even with all that, Daniel called the sirens the last line of defense. Why? If the phone is so reliable and the cell broadcast is so fast, why do we still need these giant horns on the roofs?
Because technology fails in predictable and unpredictable ways. Think about the edge cases. What if you are a senior citizen who doesn't use a smartphone? What if you are an ultra-Orthodox family like we talked about in previous episodes who uses kosher phones that might not have the latest apps or data capabilities? What if your phone is dead? What if you are in the shower? What if you are sleeping and your phone is in the kitchen? The siren is a forced notification. You cannot opt out of it. You cannot silence it. It is an environmental alert rather than a personal one. It changes the physical state of the space you are in.
That is a powerful way to put it. It changes the physical state of the space. It is almost like the sound itself becomes a physical barrier or a command that you can't ignore. It reaches into your lizard brain.
It is designed to trigger a biological response. The frequency of the Israeli siren is specifically chosen to be in the range where human hearing is most sensitive, typically between 400 and 800 hertz. That rising and falling frequency isn't just for show, it is designed to prevent your brain from tuning out, a steady tone. Our brains are very good at filtering out constant noise, like a hum of a refrigerator, but a fluctuating tone creates a sense of urgency and cognitive dissonance that forces you to move. It is psychoacoustics at its most practical.
I wonder about the engineering of the sirens themselves in terms of durability. These things sit on roofs in the middle of the Middle Eastern sun, through dust storms, rain, and heat for years. They have to work perfectly, the one time they are needed.
They are built like tanks. The electronic ones use high-grade aluminum or composite horns that won't corrode. The amplifiers are often housed in temperature-controlled, NEMA-rated enclosures that protect against dust and moisture. And most importantly, they have massive battery backups. A siren that doesn't work during a power outage is useless. Most of these units can run for several days on battery power, even if the main grid is cut. They also perform silent tests. The system can ping each siren to check the health of the amplifier and the drivers without actually making a sound. It measures the impedance of the speaker coils to make sure they haven't burned out or been damaged.
So the home front command knows if a siren in a specific neighborhood in Jerusalem is down before an emergency even happens.
They have a dashboard that shows the status of every single siren in the country. It is a managed network, not just a bunch of independent speakers. If a siren fails its silent test, a technician is dispatched immediately. It is treated with the same level of importance as a broken water main or a downed power line.
Let's talk about the calibration again. You mentioned the polygon system. How do they handle the spillover of sound? If I am in a safe zone, but I am right on the border of a polygon that is under fire, I am going to hear that siren, right?
You will. And that is actually one of the biggest complaints and challenges of the system. It is called acoustic spill. If the wind is blowing the right way, you might hear a siren from 2 kilometers away. This is where the engineering of the speaker arrays comes in. Instead of a single omnidirectional horn, modern sirens often use directional arrays. By stacking the speakers in a certain way, engineers can shape the sound beam to be more horizontal, reducing the amount of sound that escapes upward into the atmosphere and focusing it on the ground level. They can even aim the sound away from certain areas to minimize false alarms in neighboring zones.
It is almost like beamforming in Wi-Fi, but for massive sound waves.
Precisely. It is acoustic beamforming. By adjusting the phase and the physical orientation of the drivers, you can create constructive interference where you want the sound to be loud and destructive, interference where you want it to be quiet. It is never perfect, but it is a lot better than it was 30 years ago. They also use staggered activation. If 2 sirens are close to each other, They might be slightly out of sync to prevent phasing issues, where the sound waves cancel each other out and create a quiet spot right where you need it to be loud.
What about the internal sirens? Daniel mentioned the non-GSM emergency network for ultra-Orthodox communities. We have touched on this before, but it is such a fascinating subset of this engineering.
Yeah, it is a great example of social engineering meeting mechanical engineering. In neighborhoods where people don't use the internet or smartphones for religious reasons, the Homefront Command has distributed special home sirens. These are small devices that plug into a wall outlet and listen for that specific RF trigger signal we talked about earlier. When the signal for their polygon is broadcast, the device in their living room starts beeping. It is basically a personal air raid siren. It is a way of bringing that last line of defense inside the home for people who are otherwise disconnected from the digital alert layer. They even have vibrating pagers for the deaf and hard of hearing community that are linked to the same system.
It is amazing how much thought goes into making sure no one is left behind. But I want to go back to Daniel's prompt about the interception he saw. He mentioned seeing fireballs in the sky. That means the system worked. The radar saw the threat, the sirens went off, the people went to shelters, and the Iron Dome engaged. But there is a psychological component to the siren that I think is part of the engineering too. It is the sound of the state taking care of you in a weird way.
Oh, absolutely. The siren is part of the UX of survival, as we called it in episode 824. If the siren goes off too late, people lose trust in the system. If it goes off too often for false alarms, they get alert fatigue and stop going to the shelter. The entire engineering goal is to provide the golden window, that 15 to 90 seconds of warning that gives you just enough time to get to safety without giving you so much time that you start wandering around looking for your camera. In some areas near the border, that window is as short as 15 seconds. The engineering has to be flawless to make those 15 seconds count.
15 to 90 seconds. That is not a lot of time, especially if you have a toddler like Ezra, or if you are on a high floor of a building.
It is a terrifyingly short amount of time, and that is why the multi-layered system is so important. If you get the notification on your phone 2 seconds before the siren hits, those 2 seconds might be the difference between making it to the safe room and being caught in the hallway. The siren is the confirmation. For many people, they see the app notification, they think, is this real? And then the siren starts and their lizard brain takes over. It validates the digital alert. It turns a notification into a reality.
I also think about the engineering of the safe room itself, which we covered in episode 601. The siren is the trigger, but the safe room is the destination. The two are inextricably linked. The siren has to be loud enough to be heard inside a reinforced concrete room with a heavy steel door.
That is a great point. If you are already in your mamad, the Hebrew term for the safe room, because of a previous alert, you still need to know when it is safe to come out or if another wave is coming. The sirens are calibrated with the assumption that people will be behind concrete. This is why the decibel levels are so high. Concrete is a fantastic sound insulator. A standard concrete wall can reduce sound by 40 to 50 decibels. So if the siren is 80 decibels outside, it might only be 30 or 40 decibels inside, which is about the level of a quiet conversation. If you are sleeping, that might not wake you up.
So the engineering has to account for the worst case listener, someone sleeping in a soundproofed room.
This is why some modern apartment buildings in Israel are now being built with internal alert speakers wired directly into the building's infrastructure. It is an extension of the siren network into the very walls of the home. These speakers are connected to the building's emergency generator and are triggered by the same RF signal as the big horns on the roof. It is the ultimate evolution of the last line of defense.
It feels like we are moving toward a world where the siren isn't just a thing on a roof, but a pervasive alert state that the entire environment enters.
That is the trend. We are seeing integration with smart home systems. In the future, your smart lights might turn red. Your TV will automatically switch to the Homefront command channel, and your smart speakers will play the alert tone. But even then, Corn, I bet we still keep the big horns on the roof.
Just for the last line reason?
Partly, but also because there is something about the communal nature of the siren. When you hear that sound, you know that everyone in your neighborhood is hearing it too. You know your neighbors are moving to their shelters. It creates a shared reality. In a crisis, that shared reality is a powerful psychological tool. It reduces the feeling of isolation. You aren't just a guy with a vibrating phone, you're part of a community that is collectively taking action to stay safe. There is a social cohesion that comes from a shared acoustic environment.
That is a really profound observation, Herman. It is the social engineering of the siren. It is the sound of, we are in this together.
And it works. Israel has one of the highest compliance rates for emergency alerts in the world. People take it seriously because the system has proven its reliability over decades. It is a high trust system built on high-end engineering.
I want to touch on something Daniel mentioned, the German-made sirens. Why Germany? You would think Israel, with all its tech prowess, would be making its own sirens.
It is mostly about the specialization of labor and the history of acoustic engineering. Germany has some of the strictest noise pollution and public safety regulations in the world, and companies like Hormann and Sonnenberg have been building high-powered acoustic systems since the Cold War. They have the testing facilities, massive anechoic chambers, and wind tunnels to perfect the horn shapes for maximum efficiency. When you are buying a system that life or death depends on, you go with the people who have been doing it the longest. That said, the brains of the system, the networking, the encryption, the radar integration, that is all Israeli developed by companies like Beeper Communications and the major defense contractors. They take the German hardware and give it an Israeli brain.
So it is a global engineering effort to keep a local population safe.
It really is, and it is constantly evolving. They are currently testing new types of directional arrays that can provide even more precise coverage. They are also looking at using the Siren network for mass voice communication in the event of a total cellular blackout. Imagine the siren wailing and then a clear, calm voice coming over the speaker telling you exactly where the nearest water distribution point is or what the specific nature of the threat is. It turns a simple alarm into an information channel.
That sounds like something out of a sci-fi movie, but in a conflict zone, it is just practical necessity. It is about maximizing the utility of every piece of infrastructure.
It is the ultimate fail-safe. If everything else, the internet, the cell towers, the power grid goes dark, you still have these independent battery-backed towers that can talk to the entire population.
You know, we have talked a lot about the technology, but I think we should address the practical takeaways for our listeners. Not everyone lives in a conflict zone like Daniel, but the principles of this multi-layered alerting system apply to everyone. We are seeing more extreme weather events globally, and the lessons from Israel's Siren network are universal.
Whether it is a tornado in the Midwest, a tsunami in the Pacific, which Daniel mentioned his wife Hannah remembers from Texas, or a wildfire in California, the three-layer rule is something everyone should implement.
What is the three-layer rule?
It is my term for personal emergency preparedness. Layer 1 is your active notification. Have an app on your phone with critical alerts, enabled so it bypasses your silent switch. On iPhones and Androids, you have to specifically grant permission for this. Layer 2 is your passive notification, a weather radio or an emergency alert system that lives in your house and has its own battery backup. These devices, like the ones from Midland or Sangian, stay silent until a specific digital code is broadcast by the National Weather Service. And Layer 3 is your environmental awareness, knowing where the physical sirens are in your town and what they sound like.
It is amazing how many people don't know what their local sirens sound like. In some places, they use the same siren for a fire volunteer call as they do for a tornado warning, just with a different pattern.
And that is a failure of UX design. If the user has to count the number of beeps to know if they are about to be hit by a tornado or if the local fire department is just heading out, you are increasing the cognitive load during a crisis. The Israeli system is successful because the wail means one thing and one thing only: seek shelter now. It is unambiguous.
We actually talked about this cognitive load issue in episode 824, when we looked at why public shelters often fail. If the instructions aren't clear and the alert isn't unambiguous, people hesitate. They look for social confirmation. They look at what their neighbors are doing. And in these scenarios, hesitation is the enemy.
The engineering of the siren is designed to eliminate hesitation. It is a binary signal. Sound equals danger. Silence equals safety. It is the most basic form of communication, and that is why it is so effective.
Before we wrap up, I want to go back to the interception Daniel saw. He mentioned seeing it while recording the prompt. That is a testament to the speed of the whole system. From the moment the rocket is launched in Lebanon or Gaza, to the radar detection, to the polygon calculation, to the siren triggering, to the Iron Dome interceptor hitting its target, we are talking about a window of sometimes less than 30 seconds.
It is one of the most complex automated loops ever engineered. It involves radar physics, ballistic mathematics, high-speed networking, and mechanical acoustics all working in perfect harmony. And the most incredible part is that it works thousands of times with a near-perfect success rate. But as Daniel said, even with all that Star Wars tech, the sound of that siren remains the most vital part for the person on the ground. It is the human interface for a machine-speed war.
It is the bridge between the digital and the physical. It takes a radar blip and turns it into a physical action by a human being.
Well said.
So, for our listeners, what is the one thing they should take away from this? Besides the 3-layer rule?
I think it is an appreciation for redundant simplicity. We spend so much time chasing the next big digital thing, but sometimes the best engineering is just making a very loud noise in a very smart way. Don't disable those emergency alerts on your phone. Don't ignore the test of the sirens in your town. They are there because, eventually, the high-tech layers will have a gap, and you will need that last line of defense.
And if you are in a place like Jerusalem, like Daniel, you realize that these systems aren't just features, they are the infrastructure of life. They are what allow a city to keep functioning even under incredible pressure.
They really are. It is the engineering of resilience.
This has been a fascinating dive, Herman. It is one of those topics that feels weird, because we don't think about it until we need it, but the engineering behind it is as deep as anything we have covered on the show. It is easy to take a loud noise for granted, but when you realize the math and the physics required to get that noise to the right person at the right time, it is staggering.
It is the ultimate silent partner in public safety, until it isn't silent anymore.
Right, and then it is the only thing you are listening to. Well, I think that is a good place to wrap this one up. We covered the physics of sound, the transition from mechanical to electronic sirens, the polygon precision of the home front command, and why the analog siren is still the king of emergency alerts.
It was a great prompt from Daniel. It really pushed us to look at the intersection of acoustics, networking, and human psychology. It is a reminder that engineering isn't just about building things, it is about solving human problems in the most reliable way possible.
And hey, if you are enjoying these deep dives into the tech that runs our world and sometimes saves it, we would really appreciate it if you could leave us a review on Spotify or Apple Podcasts. It genuinely helps the show reach more people who are as curious as we are.
Yeah, it really does make a difference. And if you want to dig into our back catalog, we have over 800 episodes now. If you like the survival aspect of today's show, check out episode 601 on the engineering of safe rooms or episode 745 on cell broadcast technology. You can find all of those at myweirdprompts.com.
You can also reach out to us at show@myweirdprompts.com if you have a topic you want us to explore, or just use the contact form on the site. We love hearing from you guys, especially when you are out there in the world seeing this tech in action like Daniel was.
And a quick reminder that our theme music and all the music you hear on the show is generated with Suno. It is pretty amazing what you can do with AI these days, even if it can't quite replace the raw power of a 130 decibel air raid siren.
Not yet, anyway. Alright, I'm Korn.
And I'm Herman Poppleberry.
Thanks for listening to My Weird Prompts. Stay safe out there, keep your alerts turned on, and we will talk to you in the next one.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from sloths